Hi there. In this video, we're going to take a look at how energy is transferred from one place or one object to another place. All of Earth's processes involve the transfer of energy. So this is a really important concept to understand. We're going to take a look right now at how heat is transferred and how light is transferred through solids and liquids and gases, since the Earth's spheres are made of those three states of matter. So you've probably experienced a situation like this, where maybe you were at a campfire, either at camp or on a beach, and obviously part of this image is warmer than the rest. And the fire would be the warmer part, and the surrounding area is the cooler part. Well, energy always moves from places where there is a high concentration of energy, which we call the source, to regions of lower concentrations of energy, known as the sink. So in this case, there's going to be energy traveling from the fire, which is the source, outwards to the people, which would be the sink, because they are cooler than the fire. And the energy is going to continue to transfer until the energies are equal. And of course, that's what we call dynamic equilibrium. So in all of the Earth's systems, energy always flows from a source to a sink until both have reached dynamic equilibrium. So there's three methods by which energy is transferred. The first one is called conduction. Conduction occurs when heat makes the atoms in a molecule start to vibrate. And those vibrations cause the molecules or the atoms to bump into the ones next to them. And they start to vibrate. And the energy transfers to the next one. And they start to vibrate, and so on and so forth. Conduction is most effective in solids, especially in metals. When you think about the tools we use to cook with, our pots and our pans are made of metal, because metals are excellent conductors. When you make scrambled eggs or anything that you cook in a pan or a pot, do the eggs or does the food actually touch the fire? No, obviously it doesn't. What happens is that the heat from the flame makes the molecules at the bottom of the pan start to vibrate. And those start to shake, and they start to knock into the molecules above them, which makes them shake. And they start to knock into the molecules above them and collide. And the collisions continue upwards through the pan until eventually the molecules in the pan are colliding into the molecules in the egg. And so the bottom of the egg starts to vibrate. And then the collisions transfer to the next layer of egg, and so on and so forth. So that's what happens when you cook. Okay, the energy is getting conducted through the molecules by the vibration of atoms. When you hold a warm drink, the same thing happens. The heat inside the cup is causing the molecules of the mug to vibrate, and they vibrate outwards through the mug until it reaches your skin. Okay, so that's the process of conduction. Happens in solids, mainly in metals. The next type of energy transfer is called convection. Convection is how heat transfers in a fluid. Now, in real life, when we think of fluids, we think of liquids. But in terms of science, a fluid is considered anything where the molecules flow. So liquids and gases are both considered fluids. When heat transfers through a liquid or gas, it happens because of differences in density. We already know that when you heat up something, it becomes less dense. And when things are less dense, we know they rise. On the flip side, when things are cooler, they become more dense, and therefore they sink. So again, convection happens in liquids and gases. When you heat up a pot of water to cook pasta, the bottom of the water is the hottest, because it's closest in contact to the flame. What happens is this hot water becomes less dense and it rises upwards. As it rises away from the heat source, the water becomes cooler. And we know that when things are cooler, the molecules contract and they become more dense, and so they start to sink. And so this energy will sink back down, and when it gets close to the heat source, it'll warm up again, and it will create this convection cell, or this convection current. And that's how energy transfers in liquids. If you were to put elbow macaroni in this pot of water, you would actually see the macaroni moving in circles because the energy is transferring in a circular path. Heaters work the same way. When you turn a heater on in your room, the warm air comes out of the heater and it's less dense, so it rises up. As it rises, it cools and it becomes more dense and it sinks down. And then it would get heated again and it would rise up. So in your room, there would be this convection cell, or this convection current, where the air would be flowing. Warm air rises, cooler air sinks. Most of the Earth's global wind patterns are also caused by convection. We're going to take a look at this diagram in our reference tables in a few weeks. But what you'll notice right now is all around the Earth are convection cells, and those cause our global wind patterns to form. So this happens in the atmosphere. When you go to the beach on a hot summer day, most people don't go in the water. People go to the beach because there's a cool breeze on a hot summer day. The cool breeze, which is called a sea breeze, is part of a larger convection cell. So the land gets heated by the sun, the air gets very warm, and it rises. As it rises, it cools down and it sinks, and it creates this convection cell. So another example of convection in the atmosphere. Convection also happens in the oceans, and this is how energy flows within our oceans. We know that the equator, the equatorial region, is warmer than the polar region. So the equator area is a heat source, and the polar regions are sinks, and it creates a flow of energy through the oceans. We've also studied plate tectonics, so we know that convection occurs in the Earth's mantle, and this is how the energy is transferred from the core upward to the surface of the Earth. And of course, that drives plate tectonics. So convection cells happen in many different parts of the Earth. The third type of energy transfer is called radiation. Radiation is how energy travels when it is in the form of an electromagnetic wave. So we've already studied the electromagnetic spectrum. Radio waves, microwaves, infrared radiation, visible light, UV rays, X-rays, and gamma rays, these all travel through the process of radiation. What's important about radiation is you don't need to have solids, liquids, or gases. Energy that travels via radiation can go right through air and right through space. Space is nothing. There's nothing there. We say that no medium is required. That means that this type of energy does not need anything to go through. So right now there are radio waves traveling in your room. When you put food in the microwave, the energy goes right through, from the machine right to the food. When sunlight travels through space, it goes right through nothingness that's in space. So this is the third process. This is radiation. And again, the key things here is this is how electromagnetic energy travels, and no medium is required. So tomorrow we're going to sort of put this all together. We're going to look at some objects, and we're going to actually do a lab tomorrow. We're going to explore a few of these types of energy transfer, and by doing so, it'll give you a better understanding of how we can make systems more efficient, and we can look at ways where energy is sometimes lost while it's getting transferred. See you tomorrow.